Okay, we're going to be looking at section 2.2 today for MAC 1105, where you are looking at graphs and describing whether or not the graph is increasing or decreasing. So we start off with a couple of definitions, which is a very technical way of describing how a function is increasing. So I'm going to try and help you understand that, because the goal is, if you do take more mathematics courses, you eventually become familiar with how to read this notation. So what you're seeing right here is they're talking about f of x. And if you recall, when we use the notation f of x, regardless of the subscript that's hanging here, that really means the y values. So what they're trying to say here is that you could put your finger on any x value that you like, and we will call that your first x value. And what this means as a whole is that when you do stand on that particular x value, whatever you choose to stand on as your first x value, there is a y value associated with it. And that's what f of x sub 1 actually means, that your first y value is designated as f of x sub 1, and then you're going to move to another x value, and there will be a y value associated with that. So what this says is that if the y value associated with x sub 1 is less than the next y value, that means that the graph is going up. And it's much easier to see when you're looking at it visually, but that's basically what this says. If your first y value is less than your second y value, that means the y values are getting bigger as you move from left to right. All graphs are analyzed sliding your hand from left to right on the graph. So when the y values get bigger, it's called increasing. This says the opposite of that, that you could put your finger on any x value you like. It will have a y partner. And then you can move to another x value. And what we're saying is that if the y value here is less than the y value that you were first on, that means that the graph is going down. And that's what we mean by decreasing. So just technical way of describing increasing and decreasing. A constant function, that means that it's just a flat line as you scan the graph from left to right. That would mean that whatever x value you decide to place yourself on to begin with, it will have a y value. And then when you move to some other x value that you have chosen to move to, it will also have a y value. And if those two y values are equal, that means you're talking about a straight line. So increasing on the graph is going to look like this. Again, you're always scanning the graph from left to right. It'll be a portion that's going up with respect to the y values. This would represent f of x sub 1, and then you move to some other point and the y value is higher. This would represent f of x sub 2. That's kind of a picture of this definition. Decreasing, that means you've decided to stand on some original point. Then you move to some other point and it is lower with respect to the y value. So this would be a picture of this second definition. And then when you are looking at a graph and you're standing on a particular y value or particular x value, which will have a y partner, and then all of a sudden you move to another x value who also has a y partner, and it would look like that. So these are pictures of increasing, decreasing, and constant. So you're going to be looking at that as you go over these diagrams. And you're going to be answering in interval notation, which is why you saw it in chapter 1, even in MAC 1033. You learn to really get a grasp of interval notation because you'll be expected to use it quite often. So for instance, as you're looking at number 1, it says describe the open intervals. That means parentheses around the numbers that you're going to mention in the interval. Open intervals on which the function is increasing. Okay, remember, you're scanning this graph from left to right, and you're looking for either sections of the graph that are going down, that's called decreasing, or sections of the graph that are going up, that's increasing, or sections that are flat, which would be called constant. So you see there are no flat pieces. You are decreasing as you come out here. By the way, this leg flares out. It actually gets wider and wider and wider. In fact, it is gradually moving to the left, which we call negative infinity. Because when you are answering questions that concern whether it's increasing or decreasing, please notice that I have highlighted in a box for you or tried to bring to your attention the fact that you need to be using the X values. And students often make a mistake about that. They're so concentrated on looking at the Y values in order to see whether it's increasing or decreasing that they mistakenly give the answer using Y values. You do not use the Y values when you're talking about increasing or decreasing intervals. Okay, so from here all the way to here, from out here in infinity all the way to right there, that graph is falling. Okay, so what you want to talk about is what are the X values associated with this point. Right here where the decreasing stops, you're at -2, right there. The X values that are associated with this leg that flares out, those X values go all the way. They keep going. They don't stop, so we have to call that negative infinity. We can't name it with just a number. So the decreasing starts way out here in negative infinity, and it stops decreasing right at -2. If you did not get these things right on the first test, whenever you're doing interval notation, you have to mention the smaller number first, or the smaller numerical concept first, and then the larger one. Negative infinity, the numbers get smaller and smaller. You're naming an open interval, which means there are parentheses around it. Now, if you happen to go to an interval where the graph cuts off at a particular point, in other words, it actually stops at that point and has no changing behavior at that point, then you can put a bracket around the number. But right here at 2, right at this number, behavior changes. It's decreasing, and then all of a sudden it starts increasing. So from here to here, and again, this leg flares out, 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 so that we could say it's really heading eventually to positive infinity. So when you describe the increasing portion, you're going to say it starts at -2 and it continues off to negative infinity. So I think I have to switch these around. Let me put this next to the question that it belongs with. Okay. So for A, since the word that they used there was increasing, I'll put the increasing answer there. So this is, again, this pink portion is the increasing portion. Starts at -2, goes off to infinity. And again, with respect to the symbols that I am encasing these numbers with, I have to put, and that's a big reason why they say name the open intervals. I have to mention -2 because that's where the increase starts. But at that point, what do you call it? Does -2 belong to the decreasing portion or increasing? It belongs to both. And so there is changing behavior there, and you must put an open parenthesis around that number. And then around any kind of infinity symbol, and this is the infinity, you're mentioning that with respect to, you're wanting to mention an X value, but what X value do you mention? Because the X values just keep continuing and continuing as that increases. So you are just calling it positive infinity. All infinity symbols get encased with open parentheses. Okay, then the next word that's used is what was the decreasing portion. I described that first when I began talking about this graph. It starts out at negative infinity, and that decreasing behavior stops at -2. So for part B, we'll put negative infinity. all the way to -2. Okay, open intervals on which the function is constant. You have no interval where the function is constant, because if you did, it would be a flat portion. So for part C, the answer is there is none. There is no constant portion. Okay, number 2. And then there's just many questions that have to do with this same thing. Where is it falling? Where is it rising? Where is it flat? Okay, so again, you're going to be practicing that as the main concept in this section. Open intervals on which the graph is increasing. There is no increasing portion. This is called constant right here because it's flat. I'll just abbreviate that. And this is a falling portion. In other words, the y values are decreasing. So this is decreasing. So when you go to name these, you're going to name this right here as your constant portion. You need to talk about where it starts being constant and where it stops being constant. The y value is the x value associated with the end, the rightmost end of the constant portion is -2. And then what's out here, those x values are called negative infinity. Remember, you are concentrating on what are the x values where the particular interval that you're describing, what are the x values associated with either end? Negative infinity and -2. Okay, so where is it increasing? There is no increasing portion, so I'll just say none. Where is it decreasing? From -2 all the way to these x values get bigger and bigger and bigger, so we call that positive infinity. That leg flares, and anytime a leg flares, whether it's pointed up or pointed down, it means it's continually moving towards infinity, either negative or positive infinity. So this would be your decreasing portion. Okay, so decreasing portion in part B starts right there at -2 where the constant portion stops. So -2 all the way to positive infinity. Open intervals and where the function is constant. Described that already and highlighted it for you in blue, from negative infinity to -2. Okay, and those are all 3 answers there. Moving to the next page where you are doing more of the same on this next problem. You're doing number 3. I've got another picture there. More activity on this problem. So let's see. Again, these legs right here, they flare outward ever so slightly. It's a very gradual flare, but this leg gets wider and wider and wider. So you can it doesn't go straight down. I mean, it almost looks like it does, but it actually gets wider and wider. So be aware of that the legs on the left and the right, it'll be indicated by these arrows typically, will mean that it flares out in that particular direction. So the leftmost leg flares to the left, which means it flares into x values called negative infinity. This leg right here, the rightmost leg, flares to the right, which means it goes off to x values that are called positive infinity. Keep that in mind because it's part of the interval. Okay, so as we talk about this leftmost leg right here, scanning this graph and all graphs from left to right, the y values are increasing, increasing, increasing until we get right there. Okay, so this is an increasing portion until you get right there. What other increasing portion do we have? I'll put those in blue. Right in there, from 3 to 4. Okay, so from negative infinity all the way to an x value. Remember, you're using the x values when you talk about any kind of an interval. to the number 2, it's increasing. And then it's also going